we are going to discuss about chapter 2, that is muscular system. In chapter 1 we have discussed about skeletal system. In chapter 2 we are going to discuss about muscular system. Before we enter into the parts of this chapter, I would like to give a small introduction. The main and primary function of this muscular system and skeletal systems are support and movement. The primary functions of skeletal and muscular systems are support and movements. Support gives shape, look, size to an individual, where movement gives the movement of the body. See, support gives shape, look and size to an individual, where movement functions for the movement of an individual from one place to other place or extension of the body parts like this. And keep in mind that skeletal system provides attachment to the movement muscular systems. Skeletal system give attachment to the movement of muscle system. Proper functioning of muscular system improves efficiency in an individual. Proper functioning of muscular system provides or improves the efficiency of an individual. In this chapter, we have 8 different parts. They are properties of the muscle, types of muscle, mechanism of muscle contraction, muscle of body, function of muscles, effects to exercise over muscular system, meaning of strength, muscular strength, development, exercise. Now we are going to discuss about the first part, that is properties of muscle. Almost every single movement of a human body is due to the contraction of muscles. Every single movement in a human body is due to the contraction of the muscles. See, this muscle provides movement, second, it assists in blood circulation. Second is, it assists in blood circulation in a body. Third, they protects and hold. Third property of muscle is they protect and hold the abdominal organs. Fourth, it gives shape, size, etc. to a human body. It gives shape, size, etc. to a human body. Keep in mind, students, muscles give movement to an individual. It assists in blood circulation in the body. It protects and holds the abdominal organs in our body. And also it gives shape or size to an individual. Many of our muscles work under our control. Our body consists of various muscles and most of the muscles work under our own control. When we walk or when we take part in sports, these muscles work according to our wish. What we want to do, these muscles work according to that. These are called skeletal or voluntary muscles. Now we are going to deal with part 2, that is types of muscles. There are 3 types of muscles in our body. They are voluntary muscles, second involuntary muscles, and third is cardiac muscles. There are 3 types of muscles in our body. One is voluntary muscles, second is involuntary muscles, and third is cardiac muscles. Voluntary muscles. These muscles work according to the will of a person. They are called voluntary muscles. Clear, students? These voluntary muscles work according to the will of a person. They work under the command of CNS, that is Central Nervous System. They work under CNS, that is Central Nervous System. These muscles are attached towards the bones. Thus, they are also named as skeletal muscles. These voluntary muscles are also known as skeletal muscles. Why they are called as skeletal muscles? Because they are attached toward the skeletal system. When we view under the help of a microscope, they look like straightened in shape. You will be seeing the picture of this voluntary muscle. These muscles work under the will of a person. They work under the command of CNS, that is Central Nervous System. They are attached towards the skeletal bones. That's why they are also called as skeletal muscles, and they are straightened in shape. Now we are going to see about involuntary muscles. Involuntary muscles, these muscles are involuntary in nature. If we want to make use or we want to make them to work, it won't. It works against or it doesn't accept the command of CNS. Voluntary muscle accept the commands of CNS. Involuntary muscles does not accept this command from CNS. They work according to the need. They even work when we are at sleep. These muscles are mostly found in digestive tract and blood vessels. For example, we can take our stomach. We eat the food, it stores inside the stomach. These involuntary muscles push the food into the blood vessels. This is due to the presence of involuntary muscles. Clear, students? Keep this in mind. I am having my food, the food is stored in my stomach, and this involuntary muscles, without receiving the command from the CNS, it starts to push the food to the blood vessels. They are spindle in shape. They are spindle in shape and provide smooth lining over blood vessels and digestive tract. Keep in mind, they are spindle in shape, where the voluntary muscle is straightened in shape. This is spindle in shape, and they are providing smooth lining over blood vessels. And third, we are going to deal with cardiac muscles. Cardiac muscles are also involuntary muscles. Cardiac muscle is also involuntary muscle, but it is not like involuntary muscle. This is different kind of involuntary muscles. their shape is different from this involuntary muscles. Keep in mind, this is another type of involuntary muscle, and the shape of this involuntary muscle or cardiac muscle is different from involuntary muscles. They are found only in our heart. Cardiac muscles are found only in the heart and work throughout life of a person. This cardiac muscle works towards the life of a person. Till a person is alive in this earth, this cardiac muscles keep on working. Where voluntary muscle works when we want, involuntary muscles work when there is a need for them to work. But cardiac muscle is not like that. It's a continuous process, works throughout our life. Cardiac muscles are change-shaped rectangular muscles which provide continuous contraction along with passive rest. When we keep our hand over the heart, we can find that heart goes in, comes out, goes in, comes out. This is the contraction of the muscle along with passive rest. They work under the command of ANS, that is autonomic nervous system. Voluntary muscles work under the command of central nervous system. Cardiac muscle works under the command of autonomic nervous system. Or we can say ANS. Clear, students? These are the types of muscle. I hope that you all are clear. Okay students, now we are going to enter into part 3 of chapter 2. That is mechanism of muscle contraction. In order to make this very clear, I am going to share a small video with explanation so that you can understand very much easier about this part. Let's enter into the video and make sure that you watch it very careful, you make notes of it.
When we're at a dance party and we've determined that this is an appropriate time to Dougie, how does our brain tell our body to do so? Well, in this video, we're going to be talking about motor neurons. Motor neurons. These are the nerve cells that come from our brain, go to our bodies, and tell our muscles that it's time to contract. So, let's start from the top. In the brain, we have what's called an upper motor neuron. So I'll just write upper motor neuron right here. An upper motor neuron sends a signal over to a lower motor neuron that I'll abbreviate right here. Lower motor neuron. And I promise I'm going to draw this out in greater detail in a moment, but just to kind of get an idea of what they do, the lower motor neuron is the direct messenger to muscle to tell it that it's time to start contracting. The upper motor neuron, because it's sending a signal to the lower motor neuron, has two jobs. One, it'll also have the job to tell muscle eventually that it's time to start contracting. The other job it has is that it has to tell lower motor neurons when it's time to stop. It'll tell them that there's no more signal coming in, so you should stop telling muscles to start contracting. So that's why upper motor neurons have two functions. So let's take a look at a lower motor neuron in better detail now. The first thing I like to draw here is called the soma. The soma is just the body of the lower motor neuron. The part of the lower motor neuron that receives the signal from the upper motor neuron is kind of branched like this. And there are multiple projections that come off right here. These guys are called dendrites. Dendrites. And they're going to receive the signal. It's where a signal is going to dock on our motor neuron. And after it docks the dendrite, passes through the station, the soma, the cell body, it's cast away along an axon that I'm drawing right here. And I've drawn this extra long because there's going to be a lot going on here. Before this slab of meat here, or muscle, receives a message. So this is our muscle, the motor end plate, or the muscle that's going to receive information from our axon right here. So one more time, when we're at a dance party and we decide that it's time to shake a leg, how do we tell our leg that it's time to shake? Well, we have this signal that's generated from the brain, travels down the upper motor neuron, and then it goes to this lower motor neuron right here. And the way I like to think about a signal, it's kind of like how I think about ships in the Navy. So if this little ship right here is our signal, and it comes from our upper motor neuron, it needs to have somewhere it can dock on this lower motor neuron. That's what dendrites are for. This is where a signal is going to dock. Once it docks there, it has to pass through some type of station, this naval station, which is what the soma is. And after it passes through the station, it's going to move down the axon where it's cast away. The axon is where a signal is cast away from this motor neuron before it ends up going to muscle. But what could happen here? What problem could probably arise considering how long this axon actually is? Well, the signal could die off. It may not be able to make it all the way to the end. And that's kind of what would happen if you had a lower motor neuron injury or a lesion. If something were to happen to our lower motor neuron, we wouldn't be able to tell a muscle it's time to start contracting. Instead, you would have weakness because your muscle would not be able to contract. The same thing happens when you have an upper motor neuron injury. You're also going to see weakness because you're not able to tell the lower motor neuron it's time to tell the muscle it's supposed to start contracting. But that's not the key characteristic we see with upper motor neuron injuries. The key thing we look for is that we're not able to tell lower motor neurons to stop what they're doing. And so because of that, the lower motor neuron just keeps on telling this muscle, hey, go ahead and contract. I'm not receiving any signal from here to tell me to stop. And so because of that, this muscle is just going to continuously spastically contract. And so a key symptom or a key characteristic of an upper motor neuron injury that you don't see with lower motor neuron injuries is spasticity. And so that's what could happen if you have dissipation of a signal at the upper motor neuron. But nature has planned for this. What does she do to make sure that we don't have our signals dissipated? Well, she insulates our neurons. So I'm going to draw 3 insulating cells right here that wrap around our axonal fiber right here, or this axon. And these 3 cells, I'll label one right here. This is a single cell. It's known as a myelin sheath. Myelin sheath. That's an I. Myelin sheath. What does that mean? Well, myelin just means fatty. So, yo mama so myelin. They mean the same thing. Myelin sheath. And so we cover up the axon fiber to help insulate it. So instead of a signal dying off, it's able to go all the way to the end over here. And depending on where you have this myelin sheath cell in the body, there's a different name. In our central nervous system, which is strictly just the brain and the spinal cord, we call them oligodendrocytes. Oligodendrocytes. And that's only in the brain and the spinal cord. In the peripheral nervous system, which is literally everything else, any other nerve in our body that's not in the brain or the spinal cord, we call these myelin sheath cells Schwann cells. Schwann cells. So I've drawn 3 up here. And what's going to happen is that you're not going to have dissipation of your signal. No. Instead, it's going to continue on to this myelin cell and then jump and land on this node right here, and it's going to jump again, and it keeps doing this from node to node, or this empty space to empty space, until it finally makes it to the end of this axon, or what we call the axon terminal right here. And so this space right here, this open empty area that has nothing in it, has a specific name. We call this the node of Ranvier. Node of Ranvier, named after probably the smartest scientist ever, because he got his name on a scientific structure that literally has nothing. This is just empty space right here. And so as our signal is going to propagate down this axon here and jump from node to node, eventually it'll finally make it to our axon terminal right here, where we can then relay a message to our muscle that it's time to contract. And that's how our motor neurons work.
Students, I hope that you all have understand the contraction of muscles through this video. Now we are entering into the fourth part, that is muscles of body. The fourth part, that is muscles of body. There are around 600 voluntary muscles present in our body, and around 150 muscles are present in our head and neck. There are around 600 voluntary muscles in our body, and around 150 muscles are present in our head and neck alone. And this voluntary muscles makes 40% of our body weight. Students, now we are going to see about the muscles and how they are made. Each muscle is made up of thousands of narrow and long muscle cells. See, these muscles are made up of thousands of long and narrow muscle cells. Okay, each and every muscle is made up of thousands of long and narrow muscle cells, and these are called as muscle fibers. Muscles are made up of thousands of long and narrow muscle cells, and these are called as muscle fibers. And these muscle cells looks in this shape, and these are binded together as a bundle. These muscle fibers are connected together as a bundle and are covered with a tough layer of connective cells called epimysium. Muscles are made up of thousands of long and narrow muscle cells, and they are called as muscle fibers. And these muscle fibers are arranged in a bundle and enclosed or covered with a rough or strong layer of connective tissues called epimysium. Every muscle fiber is made up of a very large number of microscopic threads. See, each and every muscle fiber is made up of a long number of microscopic threads called myofibrils. Students, keep this in mind. Each myofibrils consists of rows of minute protein molecules, and the shape of these fibrils are like two combs. The shape of the myofibrils are like two combs, and the teeth of the combs are interlocked at the ends. Welcome back to the lecture. Now we are going to the second half parts of chapter 2. Now we are entering into the fifth part, that is functions of muscle. Now we are going to see the functions, the various functions of muscle in our body. The first function of muscle is provide shape and structure. Muscle provide proper shape and structure to individual, thus helps to maintain posture. This muscle provides proper shape and structure to an individual. The second functions of muscle is provide effort. This works as effort arm of liver in body, where bones acts as liver. In chapter 1 we have seen that bones act as a liver. So these skeletal muscles give more power to that liver bones to act with effort. Third is bring external movement. They bring external movement. They provide external movement to individual by contraction of skeletal muscles. If we want to walk, or if we want to raise our hand or do some action through our parts of the body, these muscles helps us to do that external movement. Fourth is help in fluid movements. Muscles also provide internal fluid movements by contraction of smooth muscles. We have seen in the properties of the muscles that these muscles helps the blood to flow through it. Fifth is forceful action. Skeletal muscles, that is voluntary muscles, provide forceful movement of body as they help in strength, speed and endurance. If a sports person want to run fast or if he want to jump high, these skeletal muscles give them more force, strength, speed like endurance to do the action. Sixth is provide protection. These skeletal muscles also provide protection to bones and other internal organs. We have seen that involuntary muscles protect the abdominal organs. Same thing, these muscles provide the bones and the other soft parts of the organs of the body. Seventh is brings heart contraction. We have seen that cardiac muscle. These cardiac muscles make the heart to contract throughout the life. Our heart pumps, that is due to the contraction of these cardiac muscles. Eighth is brings active life. They help to bring active life of individual by the action of muscles. These muscles help an individual to be very active. Students, are you clear with the functions of the muscles? So these are the various functions of the muscles. Now we are going to see about the sixth, that is effects of exercise over muscular system. The first effect of exercise over muscular system is gain in strength. With regular exercise, there is gain in muscular strength and power. This gain of strength is due to the thickening of sarcolemma. See, when we do a proper exercise, these muscles will get hardened, strengthened. So it helps us to gain more strength and power. If we look at an athlete, they will be working very hard in order to make their muscles strong. Why? Because it gives strength and power. Second is efficiency improvement. As a result of regular exercise, there is an increase in the number of capillaries in muscles. By this, there is faster circulation of blood. Thus, it improves the efficiency of the muscle. When we do a proper exercise, this helps
the muscle to develop more number of capillaries in it. And when this capillaries increase in our body, it helps the blood to circulate fast in our body. Lactic acid tolerance. Regular exercise increase the ability of muscle to tolerate lactic acid for longer duration. Thus, muscle delay tiredness and fatigue. When we do a proper exercise or the regular exercise, these muscles develop its capacity to tolerate lactic acid for a long time. That means the tiredness will be reduced. That's why a sports person or a person who wants to be very active, they should be involved in regular exercise. Thus, this tiredness will get delayed in a particular individual. Fourth is increase in aerobic and anaerobic endurance. A trained muscle has more aerobic and anaerobic endurance. Therefore, its capacity to work for longer duration. Without any fatigue gets improved. Which when we do a regular exercise, it helps us to work for a long time. Because a trained muscle has more aerobic and anaerobic endurance. Clear, students? Fifth is proper shape of body. See, when we do a regular exercise, it provides a proper shape of a body. Thus improves physical personality too. Sixth is faster recovery from injury. Trained muscles can recover from injury very fast. Moreover, there are less chance of injuries. Sports players always have a regular exercise. That's why whenever they get injured, they recover very fast in a short number of time. And moreover, hardly they get some or any kind of injuries. Seventh is emergency store of energy improves. The ATP and ADP sources are increased, by which muscle can provide more energy. It also increases the oxygen depth capacity, thus improves muscles efficiency. Fifth, desired strength can be developed. Systematic and scientific training can develop the desired strength and endurance. Systematic and scientific training can develop the desired strength and endurance. Faster responses. In trained muscle, the stimulus travels faster. The muscular actions response are faster. Moreover, muscles remain in torn up condition, which improves the flex action. Body remains throughout. It means a trained muscle reacts and responds are very fast. That's why when you see a person who does a regular exercise, they are very active and they are very fast. And one more thing, their muscles are like a little taut in position, which means it is not an injury. It helps them to have a flexible action and their body are active very much. 10th is efficient use of diet. Trained muscles can efficiently use carbohydrate, protein, fats, etc. as source of energy with less consumption of oxygen. A trained muscle can use the carbohydrate, protein, fat, etc. Some of the people are not able to have these kinds of food like fat and all these things, but a trained muscle can have it because it helps them to get energy from them too with less consumption of oxygen. 11th is better neuromuscular coordination. See, regular exercise improves the neuromuscular coordination by which various skills can be performed efficiently, economically and accurately. Regular exercise helps our nerves muscular system. The muscles which are both present in the nerve system and they coordinate with the other voluntary, involuntary muscles. Through this, various skills can be performed efficiently by an individual. Increase in muscle mass. The regular exercise increases the muscle mass. Increase in myoglobin content of muscles, thus controlling weight of a person. See, a person who have a long or a huge weight, the person have to do a proper regular exercise. Thus, the weight can be reduced in a person and they can become very strong too. Students, you are clear with the effects of exercise over muscles. That's what I am encouraging all of you from today onwards to have a regular and proper exercise. Students, now we are going to see about strength. Everybody used to hear this, you need more strength, I need more power and all this thing. So today we are going to learn about strength. First we are going to see the meaning of strength. What is the proper meaning of strength? Strength is an ability of muscle to overcome resistance. Ability to overcome resistance. If anybody asks you what is the meaning of strength, you should say the ability to overcome resistance. And second, it can also be defined as the amount of force a muscle can exert. The amount of force a muscle can exert. The amount of force a muscle can produce. It is an essential component for games and sports. A sports person or the person who is willing to involve in sports and games, strength is a very important component in that individual. And keep this in mind, different games require different level and types of strength. Different game requires different level and type of strength. It can be improved through some systematic training. To develop each components or each part of strength, we need to consider some things. In order to develop different areas of strength, we have to follow some of the things. First one is speed of work. In order to develop strength in your body, you should speed. You should keep on doing your work little bit faster or speeder. Second is weights or load. Whenever you do some work or lift something, it may feel heavier, but you should try to lift it up. When there's a problem in lifting, you may say, I don't have that much strength, but you have to try to lift it up. Through that also you can develop some of the areas of strength. And third is volume, which means you have to increase the time of your work. If we are working for half an hour, we should try to do that for like 45 minutes or something else. which I'm not saying about the homework and all these things, but what the works which we do, the works which we do with our body, external works, the work which we do with our body, like cleaning and all these things. We should extend little more, or we have to do more work. And for this, repetition. Students, these are for not for one day, but we have to keep it on repetition. Okay? And last is rest. We should also have a proper rest. In order to have a proper strength, you should have a proper rest also. Students, now you understood the meaning of strength. Now we are going to see about the types of strength. Simple, there is only two types of strength. One is static and other is dynamic. There are two types of strength. One is static and one is dynamic. And students, you should also keep this in mind. These dynamic have three different types. Static doesn't have any types, but this dynamic have three different types. That is maximum strength, and maximum strength. Second is expose, and third is strength endurance. Students, strength have two types, one is static and dynamic, and this dynamic have three different strength, that is maximal strength, explosive strength and strength endurance. Now we are going to see about static strength. This static strength can also be known as isometric strength. Have in mind, static strength can also be known as isometric strength. This isometric strength means it is the ability to act against a resistance or power from one or single position. This isometric strength means it is an ability to act against the resistance or power from one or single position. For example, we can take arm wrestling. We have only one position. We have only one position like this. We are not changing the position, but we are trying to resist the opponent's power in one position. This is called isometric strength. If not, we have another one example, that is weight lifting. We have only one position, like we are lifting it up and we are keeping it upside. That is called isometric strength. If not, wall pushing. We just push the wall with one position like this. That is also can be taken as an example. Now we are entering into the second type of exercise. That is dynamic strength. Keep this in mind. This dynamic strength have three different types of strength. That is maximal strength, explosive strength and strength endurance. First, let's see about the dynamic strength. This dynamic strength is also known as isotonic strength. It is related to movement, where the static strength is not related to movement, where dynamic strength is related to movement. Thus, we can say that this dynamic strength is required according to the movement. Dear students, this dynamic strength is used when there is a movement. Now we are entering into the three different types of strength which comes under dynamic strength. What is maximal strength? Maximal strength is the ability to act against maximum resistance. Keep this in mind. Maximum strength is the ability to act against the maximum resistance. It is the quality of muscle contraction to contract forcefully in short time. Means when a resistance is applied on us or against us, this maximum strength helps to contract the muscle to contract very fastly in short number of time, and this is called as power. It is more required in weightlifting, throwing, wrestling, etc. And this strength can be measured by throw attempts and powerlifting. This maximal strength can be measured by throwing and powerlifting. Now let's see into the explosive strength. Explosive strength is the ability to overcome the resistance with a high speed. In fact, there is a combination of strength and speed. In maximum strength, it is against the maximum resistance. Here, explosive strength is like overcoming the resistance. For example, if I am holding a person, he is already under a resistance. I am holding that person very tightly. But this guy is taking his strength and power to make him release from my hold. That is called explosive strength, which means I already holded him, the resistance is applied over him, and this person whom I am holding, he is applying the strength to overcome my resistance. That is called explosive resistance. And in order to apply this strength, there should be a combination of strength and speed. I am holding this person, he cannot slowly overcome me. He have to apply the strength with full speed. Then only he can come out of my holding resistance. Clear, students? And these things are very used in sports and games. And this strength can be measured by dynamometer or by jumping chinning test. The strength of explosive strength can be measured through dynamometer or jumping chinning test. Clear, students? Now we are moving to the last type of dynamic strength, that is strength endurance. Strength endurance is a combination of strength and endurance ability, that is patience ability. It is the ability to overcome resistance under fatigue condition, that is tired condition. This ability, that is strength endurance, enables a person to sustain localized muscle group for extension period. That is, when we go for a running or a marathon race, after some time we get tired. But this strength endurance helps us to overcome that tiredness, and the whole muscle body, muscle parts, the whole muscle parts work together in order to overcome that strength and to run for a long period of time. This is commonly required for long distance race, swimming, road cycling and mountaineering. Strength endurance can be measured through chin-ups. Strength endurance can be measured through chin-ups. You are clear, students? I hope that you all are clear with strength. Now we are entering into the muscular strength development exercise. How we can develop the muscular strength. three types of muscular strength development exercise. They are isometric exercise, second is isotonic exercise, and third is isokinetic exercise. Now we are going to see one by one. The first one is isometric exercise. Isometric is a word derived from a Latin word which gives the meaning same length. Isometric means same length. In this strength exercise, the length of muscles remain same. In this strength exercise, the length of the muscle remains the same throughout the workout. The exercise have no external movements, which means when we do other type of exercise, our muscles will be moving forward or backward. But when we do this isometric exercise, there will be no movement in the muscle. So there will be contraction between the muscles, but there will be no movement in the joints. It will be like same. When you do this exercise, the muscle does not increase, but the strength is very much experienced through an individual. The second type of exercise is isotonic exercise. Isotonic is a word derived from a Latin which gives the meaning of same tension. Isotonic is a word which derived from a Latin word which gives the meaning of same tension. This isotonic have two types. One is concentric and second is eccentric. We will look into the isotonic exercise first, then we will go to the types. In this strength exercise, the muscular group has tension along with movement. Means in first exercise we see there is no movement but strength is experienced, the pressure is experienced, but in isotonic there is a movement and tension in the muscle. When we do this exercise, we can see the movement in the muscles. In this isotonic exercise, the length of muscle changes like shorter or long. If I am doing exercise for my arms, so my muscle extends, it becomes longer and shortens. Some work is done during these exercises like jumping, running, lifting and all. When we do this isotonic exercise, there is tension and movement in the muscles which we can see, and this muscle shortens and long. Now we are going to see the first type that comes under isotonic exercise. That is concentric exercise. The first type is concentric exercise. It is an upward movement in which the flexure muscle becomes shortened, whereas extensor muscle became longer or lengthens. In this exercise, it will be always in upward movements, and when this exercise is done, the named flexure muscle became shorter and the extensor muscle became longer. In this exercise, one group of muscle, that is flexion muscle, became shorter, whereas the opposite group of muscle, that is extensor, relaxed. Dear students, when we do this exercise, the flexure muscle contract and became shorter, and the opposite, that is extensor muscle, just takes rest. The example of these exercises are biceps curling, lifting the dumbbells, throwing the balls. Clear students? Now we are going to look about the second type, that is eccentric exercise, which comes under isotonic exercise. It is the type of upward movement. In this action, it is very simple to understand. When this eccentric exercise is done, the extensor muscle, which often used to become longer, in this exercise it works in opposite way. That means the extensor muscle becomes shorter and flexure muscle becomes longer. Clear students? When we do this eccentric exercise, it is always in upward movement, but the simple thing is it works in opposite way. That is, the extensor muscle became shorter and flexure muscle became longer. And the main thing in this exercise is the extension muscle contract and opposite muscle, that is flexure muscle, takes rest. Clear students? In concentric, flexure muscle contracts and extensor muscle take rest, but in eccentric exercise the extensor muscle contract and the flexure muscle just take rest. And keep this in mind, the muscles which contract always become shorter. Okay students, the muscle which contract always becomes shorter and the muscle which take rest, it always grow long or lengthen or lengthens. Clear students? And the example for this eccentric exercise like lowering the weight, dipping, pushing, bench press, kicking the ball and on. Okay, now we are going to the third type of exercise that strengthens our muscle. Isokinetic exercise. Isokinetic is a word derived from Latin word which gives a meaning same motion. The word isokinetic gives a meaning same motion. This is very simple to understand, so I am trying to short it up. In other exercises, we see that one muscle does the work and other takes rest. But in this exercise, in this isokinetic exercise, both the flexure muscle and extension muscle work continuously with same movement and also with continuous tension. Clear students? In this exercise, both the flexure and tensor exercise have movements with continuous tension, and in both these muscles, that flexure and extensor muscle contract simultaneously. In previous exercise, one will be contracting, one will be taking rest, but here both will be contracting and they will be extending in full range of movement and at constant speed. And the main thing is, while doing this exercise, flexure muscle and extensor muscle develop simultaneously. When we look at the isotonic muscle, if flexure muscle is developing, extensor muscle will not develop. If extensor muscle is developing, then flexure muscle will not develop. But here in isokinetic exercise, both the flexure and extensor muscle develop simultaneously. These exercise requires special equipments like cycling, swimming, weight training machines. Like cycling machine, swimming and weight training machines and on. You are clear students? And now we are finishing the chapter 2, and in our next class we will be going to the games section. I hope that you all have enjoyed our class. Make notes of all the lecture which I have taught today. Prepare it well, learn well, and I encourage all of you to have a constant exercise. And stay home, be safe, save yourself and your household. Thank you.